Okay, well, good morning, everybody. My name's Halsey from Canary, Wharf, Contractors. Although I work for a building company, I've always been involved in the lift industry. My whole career has been spent dealing with lifts. Not so much a theoretician, but more a practitioner, I think. That's the way I like to perhaps view myself. So not looking too much at the theoretical things we've been talking about this morning, but the practical applications of those and how they can actually work for the buildings that we're building and how that can sort of contribute to what the industry can offer. So one of the things that struck me is that when we talk about modern group control systems in office buildings, we almost by default defer now to destination control systems. We very rarely say, okay, let's start off with a conventional system, see what that can offer, and then compare that to destination control and see what that provides. So there is this difference between the two. And one of the things that we don't really seem to consider at all is hybrid systems. Now, hybrid systems have been around for a long time. There are combinations of two. They seem to offer a bit of an ideal. The upbeat booster for the use of destination controls from the main lobby, and also then the two-button and control from the other floors, and to give you the additional handling capacity that can provide. So I thought it'd be an idea to have a look at that and just examine that and see what are the benefits of each system, how do they compare to each other, and what do they offer. So really the view was, what are the pros and cons for each particular system? How do they perform? What do they do for us? Do they give us any benefits in service? So we'd like to have a look at that as well. And then look at some of the challenges that hybrid systems bring for the users. Because for us as contractors and delivering buildings to people that are going to use them, the interface with the user is absolutely important. We just want to make sure that the life of those people is easy, things that we provide them with are easy to use. So if I can drive this. Just to define a little bit of what we're talking about, what we're talking about here is hybrid systems which use destination dispatching from the main floor. There are some suppliers that can provide them from other heavily used floors, so restaurants, conference floors, etc. And we use then conventional buttons on the landings of the upper levels. So that's what we're looking at. And the paper only really, and the presentation only really covers hybrid systems in modern office buildings. It's not really looking at other applications in hospitals or other areas of public use, but only in offices. What we'd like to look at is the limitations of conventional control and where it can and can't work. Benefits and drawbacks of each system. There's a study that does a comparison of looking at identical building using both systems and see what the results of that brings us. The user interfaces and customer experience. That's obviously an important part of what we're looking at. And then obviously there's some conclusions. They're my conclusions, by the way. They might not necessarily be yours, but they're mine. So if we look at the limitations on conventional control systems, one of the big things, and something that was discussed yesterday, is about walking times. If you have more than four lifts in a line, and you happen to be at the wrong end of the lobby, and you've got 5 lifts, you've got a long walking time. That has a big impact on door job times. It has an impact on the performance. So really, conventional control systems are limited perhaps to 4 lifts in a line, a maximum of an 8-car group. Certainly, they're not particularly good where all lifts in the building don't serve all floors. This is something that we've discussed before. It's a very difficult thing to manage that with conventional control. You end up with special buttons on the floors to get you to special floors. And of course, before you know where you are, everyone's pressing all the buttons because they're not quite sure which one's going to get them there, but they just want to get in the lift as quickly as they can. Although not covered, double-deck installations where all the lifts serve all the floors in the zone, you really do need destination control to make that work. So it does not really discussed here. So just looking at a typical lobby to sort of reinforce the argument on the length of the lobby. This is just taken from some ISO standards on shaft sizes and lobby sizes. And clearly, if you add another lift to that, the walking time from one end of the lobby, if you happen to be at the wrong end of the lift arrives, is quite considerable. You could be looking at sort of 8-9 seconds. And clearly that's going to have a big impact. You've got to have long dwell times to cater for that. If we look at a building that we have not all the lifts serving all the floors, this is not untypical of a building we're looking at the moment. But for anybody that's been on site at midnight on a Sunday trying to make something like this work for a Monday morning will appreciate the difficulties. It's very hard to make conventional systems work in those sort of formats. So conventional control really does lend itself to that type of application. If we look at the pros and cons for destination control, obviously all things we're familiar with, but it identifies a number of travelling passengers. It groups passengers according to their destination. It provides shorter round trip times during the up-peak. Can improve waiting times at the main lobby. It's an effective use of lifts. It improves up-peak handling capacity, which I think is the main key thing that we see with these systems and how we appreciate them. It also provides other benefits, like it's a better allowance for people with disabilities. So if you've got a card or you've got a button you can press to program to let people or let the system know that you've got a disability, it will give you more time to get to the lift, it will give you a bit more space in the lift, etc. And one of the great things, of course, is it manages people in the lobby. I mean, this is a big advantage. So it gets people disciplined and gets them to where they need to be. But there are some downsides to that. And one of the big downsides is it relies on all the passengers entering their call. And we know that that is a bit of an issue. And we know that that doesn't necessarily work very well. Passengers have no control in the car. Now this is some feedback we're getting from people who are using these systems. They get into the car, they find they've got no car buttons, they're in the wrong lift, they don't necessarily want to go to the floor that they think they're going to, and that's an issue for them. They find psychologically that's not particularly helpful. Ghost calls reduce inefficiencies. Ghost calls are really no-shows. So people enter a call, for some reason they don't enter the lift makes a journey, the person doesn't travel, so from that point of view it's inefficient use of the system, and it's down to the way that people use it. One of the big things is call reallocation with destination systems. Call reallocation is fairly simple for conventional systems, but when you enter your call, you get an instant allocation of the lift. Go to lift C, you're going to go to floor 6. If that lift is delayed or breaks down, there's no means of communicating that to the user. So it's very difficult for people then to understand what's happening. The systems, as far as they're concerned, the lift is no good. They've got to go back, put the call in again, and get onto another list to get them to where they want to go to. Unpopular with some users. I have to say, as much as we academically think that it's good, there's an awful lot of companies and people out there who don't like the system. And we have had a lot of potential tenants and our building saying to us that there's absolutely no way they'll consider a building with destination control. And generally that comes off the back of having a bad experience in a building that's been modernised. If you look at the history of that and try to understand a little bit of why they feel that way, it's because they've had a bad experience in a building that's been modernised. And generally those buildings are underlifted to start with, they're overpopulated, destination control is put in as some panacea to answer all the problems. It doesn't go down very well, it doesn't work very well, they suffer during the modernisation, and they have some views on that, shall we say, and some of them are very strong. There's perceived inefficiencies with destination control, which is something we look at with interfloor traffic. Is it as efficient at managing people during interfloor traffic as it is in the uppeak? So that's an issue. And of course we have this thing where people try to beat the system. They keep their finger on the button, repeat calls, trying to get to their floor. They think it's going to get them there quicker. They soon learn that if they do that, they get more space, almost get the lift to themselves. And of course they like the idea of that. Of course it absolutely snookers the system. If we look at hybrid systems, we take the benefits of destination control from the main lobby. So all those things that are there, identifies a number of passengers, groups passengers according to their destination, provides the up-peak booster, which is a big asset, and it manages people in the lobby, which is good. So from that point of view, it gives us those benefits. It gives good interfloor traffic handling. We'll look at some results of some simulations for that. It does allow space for DDA users from the ground floor, which is probably the more important one, perhaps some of the upper floors. It can use hall call allocation where you've got other floors, so you can use it with restaurants, high usage floors, so I can give you a bit of benefit for that. And it does allow for call reallocation, and for me that's the big thing. If you've got a conventional system, you put a call in, you don't know which lift is going to arrive until the gong goes and the door's open. So from that point of view, the system may reallocate the call to several lifts before it comes to you, but you don't know about that. You don't see that. And it may carry a cost advantage. Certainly there's a view that there's some cost to be gained in terms of not perhaps having touch screens on the floors, etc., etc. So there's a few things there that lend itself to it. So if we look at the things that are against it, the big thing I think is it may be confusing for users because we've got different inputs required to get you to your destination at different floors. On the ground floor you've got a touch screen or a keypad. On the upper floors you've got buttons. And probably the biggest one, I think, is the car operating panel. You've got a full set of buttons inside the lift. Sometimes they're active, sometimes they're not, and people find that confusing. It's not as effective of handling DDA passengers on the upper floors. People do try to beat the system. I have seen that happen, where people get in the lift, just wait for the COP to come active and then press their floor. Generally becomes active when the lift will respond to a landing call. That's what sort of triggers the COP. It's really limited to 8-car groups because we have the same issues on the upper floors with walking distances. It doesn't know how many passengers are travelling, so it's quite random in that respect. And one of the things that you noticed in the simulation is that the passengers may experience more intermediate stops. Now, intermediate stops, for us, perhaps knowing it's an inconvenience, but I have to say in marketing buildings, one of the things that has become important is how many times the lift stops before people reach their floor. And we've had experience with this where it's become a big marketing tool, and we've made a commitment to people, and we're hoping we're going to meet it. So that's going to be a great thing for us. Are not suitable for groups where all of this don't serve on the floor. Same thing applies to conventional controllers hybrids. So those are the sort of pros and cons for each system as I see them. And perhaps if we look at a study that's done, this is a theoretical building. It's just to run a parallel study. It's something not unfamiliar with what we might use at one of our building developments. We've got a building, 25,000 square feet per floor. What we've looked at there is the utilisation. I think, just to sort of clarify utilisation, it's the NIA and it's the usable space which people actually occupy. So what we're saying is 20% of the space there will be for circulation space, coffee machines, photocopiers. And we've used a density of 1 to 8, all floors, same number of people. So the density levels at 1 to 8 with no discount. So that was the simulation that was run. And we've looked at several key criteria that's being measured. Obviously the up peak and the lunchtime, two-way incoming and outgoing, assuming the building might be a diversified tenancy during the course of the day, not during the up peak, and an intense interfloor. And I've got to say, for the two-way and the intense interfloor, they're not referenced to any particular guide or to any particular set of criteria. It's just something I made up because I wanted to try and see how it would work. And in terms of the criteria, we've used BCO 2014. So that's slightly different to the old 2009. So that was the criteria that was set. And if we look at the results, without sort of boring you too much with the numbers, you can see that during the up peak, the waiting times are not too dissimilar. Times to destination are longer, but we do make more intermediate stops. And that would signal the fact that the lift system is working harder. It's making more intermediate stops. If we look then at lunchtime, we've got a similar situation where the waiting times are not too dissimilar, but the numbers of stops. If we look at the two-way traffic, we're in a similar situation, but the one that really sort of stands out is this one. Is this where we've got intensive two-way traffic, interfloor traffic. And what you do see is there's some significant advantages there in using hybrid systems over destination. Now I have to say this is all been done using Elevate, but it might be that some of the manufacturers will come up with different results, and that will be interesting to see, just to see if that's supported. But at the moment, it does look as if there's advantages to be had with a hybrid system, particularly in buildings with intensive interfloor traffic. So that's something to perhaps we give it some thought. If we perhaps look at the issues confronting the users, the real things with hybrid systems is the difference in the operating fixtures and required inputs. So those are different at different floors. We're asking people to do different things. And the car buttons are active at different times, and people find that confusing. So from that point of view, we need to have a look at that and see what can you do to try to address some of those issues, and how can we overcome some of those obstacles. Well, I think we can start to look at the aesthetics to start with. We could look at having the same style of touch screens and buttons on the fixtures. There's no reason why you couldn't have touch screens on the upper levels, but the touch screens display arrows instead of numbers for the floors. I think you could have a touch screen COP. Now I know there would be issues with DDA with that in terms of how that gets used. But if you had a blank screen in the car at the ground floor that didn't show any buttons at all, and when the COP became active, it illuminated as a COP. That would be far better, I think, for people than having a set of buttons in a car that are not particularly active. When they get in, it will find confusing. It would be very clear when they've got to put a cord in. You could use common graphics for screens, so you're trying to make it easier for people to understand. Everything is in the same language, it's in the same graphical form. That makes life a bit easier. And I think you could also supplement that with smart announcements. So if you're getting in at the ground floor, there could be an announcement to say your call has been pre-registered. If you get in on one of the intermediate floors above, it could say please register your call. Don't know, it's an idea, it's something that could be used, but it would give people comfort and give them a little bit of instruction. So I think there's some benefits in those sort of things. So when you start to look at that and seeing where do we think the conclusions are taking us, it would seem that hybrid systems are offering better performance when serving intense interfloor traffic. So I think that would be one of the conclusions that we've come to. But it does mean that if you're going to use it, you can experience more intermediate stops on your journey. And I think this comes back to something that was spoken about before, how intuitive are things? You know, do people want to get on the bus, and it doesn't matter how many stops it takes to get to their destination, or are they just happy to wait longer and perhaps then get to the destination sooner? So that's something else. Interfaces with hybrid systems can be confusing for users, but I think there's a way forward with trying to improve those to the point where it makes it more intuitive and gives people more comfort. Call reallocations within destination system is problematic. I think that's a big issue. I don't know if anyone has ever experienced predictive hall lanterns on conventional systems, where you press a button, the hall lantern will illuminate, people will go to that lift, and all of a sudden that goes out, and another hall lantern on the opposite side at the other end comes on because the call's been reallocated. So I'm not quite sure with destination systems how you can overcome that problem, but it is problematic. And I think I'd like to pose a question. There are inefficiencies built into destination control systems where people tailgate, where people don't show, where people genuinely find it confusing. So the question is really, does the inefficiencies of destination systems outweigh the drawbacks of hybrid at the peak and lunchtime in terms of additional stops, perhaps number of journey times? So that's just a question that's out there. Don't pretend to have the answer, and I would say that one of the things that's important in all of this is that most of the manufacturers offer hybrid as an option. Now clearly they must see that with that option there's some benefits. Now I know that one particular company focuses on the fact that it gives people comfort, passenger comfort, there's buttons in the car, but I'd be interested to know in terms of performance how they see the performance improving. And quite clearly I think you have to say that any system that can offer an improved efficiency and better levels of service deserves to be evaluated and considered as part of the design process. And I think with hybrid systems, it's something we really haven't got into in a great deal of detail, but it's something that we perhaps should. And it's certainly something that we will, at Canary will be looking at. So I think a little bit more work needs to be done, perhaps a little better understanding, but hopefully we can get to a point where we can do a proper evaluation and we can understand which system is going to be the best for which application. So that's the close of the presentation. If anybody's got any questions,
Thank you very much.
I'll try to answer them.